Hello students, today we will study asymptotes. What are asymptotes? A straight line is called an asymptote of an infinite branch of a curve if the perpendicular distance of a point P on that branch from the straight line L tends to 0 as point P moves to infinity along the branch. So say this is any curve, okay, like this, and its one branch is extending this way to infinity, okay, very long distance. And consider any point on this curve, and this is any straight line, okay, any straight line. So any straight line is called asymptote if this point and the okay, if this point is moving towards infinity and the perpendicular distance of this point from this line tends to 0, okay, as this point P moves to infinity. Okay, so this line then is called as asymptote. Okay, asymptotes normally restrict the motion of the branches of any curve, okay, that it cannot touch it. So this branch will be inside this line, okay. Now types of asymptotes. Rectangular asymptote. If an asymptote to a curve is either parallel to x-axis or parallel to y-axis, then it is called a rectangular asymptote. An asymptote parallel to x-axis is generally called horizontal asymptote, and the asymptote parallel to y-axis is called vertical asymptote. Second kind is oblique asymptote. An asymptote which is neither parallel to x-axis nor parallel to y-axis is called an oblique asymptote. Now what are the rules to find the rectangular asymptotes? Equate to 0 the real linear factors in the coefficient of highest power of x in the equation of given curve to find asymptotes parallel to x-axis. The second rule is equate to 0 the real linear factors in the coefficient of highest power or degree of y in the equation of the given curve to find asymptotes parallel to y-axis. And the third is if the coefficient of highest power of x in the equation of the curve is a constant or has no real linear factors, then the curve has no asymptote parallel to x-axis. Similar will be the case for asymptotes parallel to y-axis. Now question based on parallel asymptotes. Find the parallel asymptotes or rectangular asymptotes of the curve this. So equating to 0 the coefficient of highest degree term in y. So what is the highest degree term in y? That is y square to 0. Okay, so what is that coefficient? This is the coefficient of highest degree term in y, that's y square, coefficient of y square. This equate to this to 0 to find asymptotes parallel to y-axis. So just equate it to 0, I get x equal to plus minus a. So there are two asymptotes, x is equal to a and x equal to minus a, okay, parallel to y-axis. Again equating to 0 the coefficient of highest power of highest term degree term in x, that's x square to 0. So if we see from here, so x square, the coefficient of x square is only y square. So putting y square to 0, I get y equal to 0, 0 or y equal to 0, which are asymptotes parallel to x-axis. So this way we can find out the rectangular asymptotes. Coming to question number 2, find parallel asymptotes to the curve, this one. So here see, what is the coefficient of highest power of x? That is 2 only, a constant. Similarly, see what is the highest power of y? That is y square. And what is the coefficient of this? This is 1. So in this question we see that the coefficients of highest power of x as well as the coefficient of highest power of y these are constants. So hence there are no parallel asymptotes to this curve. These are certain exercises, questions based on parallel or rectangular asymptotes. You should try this one. Okay. For this, what you can do, you can take this denominator to this side, so y into x minus 1, x minus 2, and then also take x to left hand side minus x equal to 0. So this way you can have a fxy equal to 0 type of equation of the curve. Okay, and all this. Next is method for finding the asymptotes of general algebraic curve. So let the equation of the curve be a naught y raised to power n plus a1 y raised to power n minus 1x, a2 y raised to power n minus 2x square, and so on up to a n x raised to power n, plus similarly the second term like this, third term like this. So these different terms in the equation of curves are themselves some expressions or polynomials, okay, in x and y, right? The equation 1 can also be written as, how can we write it? If I take x raised to power n common, what will be inside y upon x terms? So I am just writing all those terms by phi and y upon x raised to power n phi and y upon x. Then similarly, if I take x raised to power n minus 1 common from here, so I get phi x raised to power n minus 1 phi n minus 1 y upon x. Okay, so polynomial of degree n minus 1, right? Then similarly we can write for all others equal to 0. So this is this equation number 2, and where phi and y upon x represents an expression of degree, expression of 100 degree in y upon x. Similarly, phi n minus 1 y upon x, phi n minus 2 y upon x are expressions of n minus 1 n minus 2 degree in y upon x, and so on. Find the values of, now what are the steps to find the asymptotes? Find the values of phi n m and phi n minus m by substituting x equal to 1 and y equal to m in the nth degree and n minus 1th degree terms respectively in the equation of the given curve. So this we have to do first. Then find the roots of equation phi n m equal to 0. So just equating this phi n m to 0, then find out all the values of m. Say these are m1, m2 and mn. Next step is, if m1 is non-repeated root of phi n m equal to 0, then corresponding value of c, because we are interested in a straight line which will be asymptote to the curve, that is y equal to mx plus c. So this value of c will be then given by this equation, okay, and the c will be equal to minus of phi n minus 1 m1 upon phi dash n m1, where phi dash n means nm means the derivative of phi and m1 with respect to m1 or m, right, provided this is not equal to 0. If phi n dash m equal to 0, then there is no asymptote to the curve corresponding to this value m1 of m. And now if m1 is a repeated root, that is occurring twice or thrice, so if it is occurring twice, then the corresponding values of c are given by this equation, where phi n double dash m1 should not be equal to 0. So this is c square upon 2 factorial phi n double dash m1 plus c1 phi n minus 1 dash m1 plus phi n minus 2 m1 equal to 0. Similarly, we can proceed when m1 is repeated 3 or more times. For example, when m is repeated thrice, we will use this equation, c cube upon 3 factorial plus phi n triple dash m1 means triple derivative plus c square upon 2 factorial phi n minus 1 double dash m1 plus c phi n minus 2 m1 plus phi n minus 3 m1 equal to 0, provided this triple derivative of phi n at m1 is not equal to 0. Okay, so this was the procedure. Now let us take up a question. Okay, find the asymptotes of the curve, this one. So what we will do now, the coefficient of highest degree term, yes, first of all we will look for the parallel asymptotes, and then we will find out the oblique asymptotes. So yes, highest power of highest degree term in x, what is that, x cube, and its coefficient is 2, and that of coefficient of highest degree term in y, that is y cube, or its coefficient is 1. Okay, therefore there are no rectangular asymptotes to this curve. For oblique asymptotes, put x equal to 1 and y equal to m. We get for this phi 3m, okay, highest degree terms, okay. So phi 3 third degree terms are these: y cube minus x square y minus 2xy square plus 2x cube. So up to this, these are the third degree terms. So phi 3m will be equal to, put y equal to m cube and x equal to 1, so minus m minus 2m square plus 2, like this. So this can be rearranged like this: m cube minus 2m square minus m plus 2. Similarly, what are the, what is phi 2m? Those will be second degree terms. So minus 7 xy minus plus 3y square plus 2x square. So this will be, now put y equal to m and x equal to 1 over here. So we get phi 2m. Okay, phi 2m like this: minus m 7m plus 3m square plus 2. Okay, next step here is put this phi 3m equal to 0 to find the values of m. So m cube minus 2m square minus m plus 2 equal to 0, and if we solve this we get roots like 1, minus 1 and 2, which are real and distinct. So these are non-repeated roots. So therefore the value of c is given by this expression: minus phi 2m upon phi 3 dash m. Okay, and what is phi 2m now? This I told you, and phi 2 1 means m is equal to 1. Here it comes up to minus 2. Similarly, phi 3 dash m. So phi 3, this, and find out its derivative with respect to m. So 3m square minus 4m minus 1. So 3m square minus 4m minus 1, and the value at 1, that is again minus 2. So therefore c is equal to minus of minus 2 upon minus 2, and it is minus 1. So for m is equal to 1, c is equal to minus 1. Therefore corresponding asymptote is given by y equal to mx plus c. So m is 1, c is minus 1, so this is x minus 1. Now when m is minus 1, again we are using that formula: c is equal to minus of phi 2m upon phi 3 m double dash. Okay, single dash. Okay, so that we are using those formula, okay, expressions, and simply putting I am value minus 1, and what I am getting is minus 2. So asymptote is y equal to minus x minus 2. Similarly, when m is equal to 2, okay, so see this, in the same expression put m, the value of m as 2, so I am getting this value as 0. So therefore y equal to 2x plus 0 and y equal to 2x. So these are all the three asymptotes to this curve. Thank you.